In our last video of our Unit 7 Day 2 log notes, we covered how to convert the logarithmic function into exponential function and practice evaluating those log functions. Today, we're going to fast forward a little bit in this next video to the inverse of log functions. So I'm giving you a function here, f of x equals the power b to the exponent x. Find the inverse. Okay, think first, what do you do? So when you hear the words find the inverse, we've done this recently. There's two steps to follow. Step 1, you are going to switch the x and y. Step 2, you will isolate the y, meaning get the y by itself. All right, so let me take that function. I'll just rewrite it to the right. F of x equals b to the power of x. And we have to follow step 1. Switch the x and y. So you know that the f of x is the y in disguise. So I'm going to replace the left side with an x. And then on the right side, it's now going to be b to the power of y. All right, step 2. This could take multiple steps in some cases. In our case, it's going to take one step. We need to get this y by itself. So the y you see is in the position of the exponent, meaning we have to get rid of the b at the base. Well, we know now that to eliminate the base of a power, you have to use logs. And the log you use has to have the base, the same base, as the base of the power. So in this case, b. Whatever we do to one side, we want to do to both sides when we're solving an equation. So on the right side, to get rid of that base b, I'm going to have to use and apply a log of base b to that right side. I'm also going to have to keep it balanced and apply log base b of x on the left side. So the right side, here's what happens. The log base b cancels with the base b of the power, and that means on the right, all we're left with is y. All right, the left side, we're just going to rewrite it. Log, just make it a little bit neater, log base b of x. So take a few things, notice a few things here. The y is by itself, and notice how what was exponential form is now in logarithmic form. And that could go in both directions. You can feel free to circle this as your final answer, but if you want to be a little bit more particular, technically the notation for an inverse function is f inverse of x. So that's what the y was from up above, would equal log base b of x. Either answer here is acceptable for me. All right, so with inverse functions, we're going to bring back something from last unit. The top sentence here says, by definition of a logarithm, it follows that the logarithmic function, really of any form, is the inverse of the exponential function that it matches. What this means is we can prove that any logarithmic function is in fact the inverse of the exponential function if we compose them with each other and end up with just that single x both ways. So you'll recognize this notation here. G of f of x equals x, and f of g of x equals x. What's written in between is just showing you how you would kind of compose the log with the exponential form. So in one case, you would put the exponent form into the log form. In the other case, you would put the log form into the exponent form. And if those two functions were in fact inverses, then you would be left with just a single x in the end. So if we were to summarize this in your own words, feel free, you can pause it, rewind, and listen to how I explained it again. But what I would suggest you do is try to summarize it in your own words, pause the video, and come back to it and see if it matches something that I'm about to write. So we were going to summarize this. We might say we need to compose both functions with each other to see if everything, I'll say except for a single x cancels out. So yours might not match my wording exactly. I'm not sure I like it entirely, but it's what I came up with on the spot. So something along those lines though. All right, so we're not going to necessarily practice doing that right now. What we are going to practice is just finding the inverse of each of these functions. So what I've given you, I believe there are 6 different problems. We're going to go through each of these and just practice finding the inverse. Some of these are a little bit trickier than the others because they involve some of those special logs we talked about in the last video. So we'll start off with a really easy one. Y equals 6 to the power of x. If we're going to find the inverse, the first step is always the same. Switch the x and y. All right, to get the y by itself, always the second step. In this case, we have to, that means get rid of the base 6 of the power. So we are going to have to log base 6 both sides. So if I log base 6 the left side, I'm left with log base 6 of x. If I log base 6 the right side, all I'm left with is y, because the base 6 and the log base 6 would cancel out. So I'm just going to circle that. There's my inverse. All right, let's stick with some exponential examples. So I'm going to go to the one right below it. This one, we're going to start, switch the x and y, but there's an extra step involved here. Instead of going right for eliminating the 4 at the base of the power, we have to get rid of that 5 first. So I'm going to subtract 5 from the other side, and then apply the log base 4 that I need. So there's an extra convention involved here because the left side contains more than just one term, like 1x. When there's more than just x, and in this case x minus 5, you have to put parentheses around the entire kind of inside piece meant to go inside of the log. In this case, here's your answer. When in doubt, just always put parentheses. We can go back up to the previous example's answer and put parentheses there if we want to. It's not wrong. In that case, it's just not necessary. So when in doubt, go for it. All right, let's go top right of the screen here. We see y equals the natural log, if you forget that from last video, of x plus 3. So the first thing, switch the x and y. And we cannot actually subtract 3 here first. The reason being, it's because it's inside of the natural log. So we have to eliminate the natural log here first. And if you remember from the last video, to eliminate a natural log, you have to do what I like to call E both sides, because the natural log is the inverse of that letter E base. So if I say E both sides, what I'm really going to do is put that E and make it look like the base of a power on both sides. So that will cancel with the natural log on the right side. The left side is now going to read E to the power of x equals, on the right side, y plus 3. So your final step is then just to subtract 3 from both sides. So your final answer for the inverse here is e to the x, and then after that, minus 3. All right, let's try the next problem right below. Y equals log base 3 of x minus 5. Very similar to the one we did above with the natural log, just this time, instead of e on both sides, we have to use the number that's at the base of the log already. So we're going to apply a base of 3, but first we do have to switch the x and the y. Let's not forget to do that. So now, since the 5 is inside of the log, we have to eliminate the log first. So I'm going to base 3 both sides, so that will eliminate the log base 3 on the right and leave us with y minus 5. So then your final answer is 3 to the power of x, and then after that, big plus 5 to get the y by itself. All right. So 2 more examples, and I encourage you to do these on your own. I will give you one extra hint for this one on the right. This log of x, or just written log x without the parentheses, think about from last video, what is the number that is not indicated where a base would normally be placed? And if you go back to the last video, it will tell you. You could also look up the common log, and it will give you that answer. So go ahead and try these 2 examples, and then check the answer key.